Hi everyone, welcome to lesson 3.4. This lesson is on congruence theorems for triangles. So we've learned about congruent triangles, and we know congruent triangles are triangles that are an exact copy of each other. So all their pairs of corresponding parts match up. They've got 3 pairs of corresponding sides and 3 pairs of corresponding angles. In our last lesson, we were practicing showing that 2 triangles were congruent by showing all 6 of those pairs were congruent. So we had to do all 3 pairs of sides and all 3 pairs of angles. So we did that, but we may have been like, this is kind of a lot of work. Do we really have to do all 6 every time? And the answer is no, we don't. We have some shortcuts. So the next 2 lessons, we're going to learn some shortcuts for triangle congruence. Our first shortcut is called the SSS theorem, and SSS stands for side, side, side. So that's this theorem right here. And this theorem says that if all 3 pairs of corresponding sides are congruent, then the 2 triangles are congruent. So all we would need to do is give a reason why each pair of corresponding sides match up, and then we can say the triangles are for sure congruent without saying anything about the angles. So that's kind of nice. So all we would have to do is say like, okay, here's a pair of congruent corresponding sides, here's a pair of congruent corresponding sides, and here's the third pair of congruent corresponding sides. This is enough to say that the triangles are congruent. So that could shorten our proofs quite a bit. Our second theorem is called the SAS theorem, so that's this theorem here, and SAS stands for side, angle, side. And this says that if 2 pairs of corresponding sides and the angle between them are congruent, then the 2 triangles are congruent. So again, we only need 3 matches between the 2 triangles to say that they're congruent. This time it's 2 pairs of sides and 1 pair of angles, and the important part is that the angle has to be between the 2 sides. So, for example, let's say that we know these 2 sides are congruent, and we know that these 2 sides are congruent. In order to say that, that's my cat, if you can hear that. In order to say that these 2 triangles are congruent, we would need an angle match, and it would have to be the angle that's between our 2 sides. So if we know specifically that this angle matches that angle, then we can say we have enough, we know that these 2 triangles are congruent. Okay, so those are 2 shortcuts. We're going to get 4 altogether. These are the first 2. And we also have a warning. So there are some things that might seem like shortcuts, but they actually don't work. And one of them is SSA. So SSA stands for side, side, angle. And SSA is actually not enough information to say that the 2 triangles are congruent. The triangles might be congruent, but they also might not be. So these 2 triangles are an example of an SSA where they're actually not congruent. So if I move these over, we see that they have an angle matching up. So this angle down there of the 2 triangles matches, and this side matches. So let me move those again. So we have this angle matching, and this side matching. And I've actually set these triangles up so that this side also matches. So here we have a side, and then an angle matching up, but these 2 triangles clearly aren't congruent, right? They're not an exact copy. This side is not the same as that side, and the rest of the angles don't match up either. So these have SSA in common, but triangles are not congruent. So if all we know is an SSA, we can't say that the triangles are for sure congruent. So we need to pay attention to the order, because we see here the one that doesn't work has the side, a side, and then an angle not between them. So if the angle is not between the 2 sides, then it doesn't work. But if the angle is between the 2 sides, then it works. All right, let's do a couple examples where we just are going to look at a pair of triangles and say whether they're congruent or whether we don't have enough information. So first one, we have AB congruent to CB, and I'm going to get us into the habit of marking given information on the figure. So first thing I'm going to do is I'm going to mark AB congruent to CB with tick marks. So one tick, one tick. And then D is the midpoint of AC, so that means D is in the middle, or it's cutting AC into two congruent parts. So AC is here, so that's cut into two congruent parts, so we know this part is congruent to that part. So we've got two pairs of sides matching up, and we actually know that the third side of these triangles matches because it's BD in both cases, and we know that BD is congruent to itself by the reflexive property, right? That was our fancy word for congruent to self. So we actually have here a pair of sides matching, a pair of sides matching, and a third pair of sides matching. So we have side, 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 which means that these triangles are congruent. So we can say congruent by the side, side, side theorem, and you can just say by SSS. That's enough. All right, let's look at another one. So PQ congruent to YZ. Let's mark that. PQ is here, YZ is here, one tick on each. QR congruent to ZX. Okay, QR is that side, and then ZX is that side. So I'm putting the same number of ticks to show that they're congruent. And now we have an angle. Angle R congruent to angle X. So for angles, we do swoops. So a swoop at angle R and a swoop at angle X. Okay, so we've got three matches. Let's check whether it meets the conditions for one of our theorems or not. We have a pair of sides, that's the pink side. Then the next thing we know, kind of going in order here, is a side, another side. So we have the yellow side. And then the next thing is an angle. So we have an SSA situation. And another way to tell this is that the green angle is not between our pink and yellow sides. So it can't be SAS because it's not between. So it's an SSA, which means we have not enough info. Okay, let's try another one. TU congruent to VU. So TU and VU, we'll put ticks on them. Angle TUW, so T to U to W, that's that angle right there. And then VUW, V to U to W, that's that angle, are congruent, so we'll put swoops on those to show that they're congruent. So we've got a side and an angle, and then we also know that UW is congruent to itself, right? Again, that's the reflexive property. So we now have two sides and an angle, and this time the angle is between our two sides. So we go side, angle, side. So that's enough to say, yes, they are congruent by the side, angle, side theorem. All right, one more. So again, we're going to look at our givens, mark what we can on the figure, and then see what we end up with. So KJ congruent to NM. KJ is here, NM is there. I'm going to put the same number of ticks on them. L is the midpoint of JM. So that means L is splitting JM into two equal parts. So here's JM. It's split into two equal parts. So JL is congruent to ML. Okay, we might ask ourselves, what else do we know? Can we get any other matches on this figure? We've got two matches from the givens. Can we get any others? And we might notice that there's a pair of vertical angles right here. So we could say this angle is congruent to that angle. Okay, so we've got three matches, two sides and an angle. But the angle, again, this time is not between the two sides. So the order that these are in is like a side followed by a side. The angle is not between them. So it's an SSA, which means we have not enough info. All right. So that's a little taste of our first two congruence theorems and how we might use them. If you're having a little trouble distinguishing between when it's SAS or SSA, just ask yourself, is the angle between the two sides or not? And you can just see that visually on the diagram. Is it between the two sides or is it not between them? If it is, then it's SAS. If it's not, then it's SSA. All right.